Hey guys, so today's project comes from a joke that I actually made a few months ago in a previous video, but is actually something that I kind of need. It was sort of a joke, but kind of serious. And that is that my soldering iron here, it's got an on-off switch on the side, but it doesn't have any sort of a timer feature to automatically turn itself off. And on at least 2 or 3 occasions in my life, and I've had this soldering iron for about 10 years now probably, at least 2 or 3 occasions, I have left this thing on for at least overnight. I think one time I honestly came back like a week later and it had been sitting running for a week. I know, it's horrible, but it did, the video I made a few months ago did actually, I want to build this. So basically what I want to do is I want to build a relay controller, basically a timer for this. So what I have set up here are all of the parts that I think I'm going to need. Unlike in my video, this is not going to be Wi-Fi controlled. I just see no reason to waste an ESP module on it. So instead, it's going to be a ATtiny controlled. So this is one of those little Digispark modules, and I think if you buy them from, I believe it's Digistump is the company that makes it, or maybe it's the other way around. Either way, I think these cost about $5 or so. So this is a really nice little module, and I think this will actually be one of my first projects with these. Now, I will say that this is not an official ATtiny, or it's not an official Digispark. I got this on eBay, and on eBay they are only about $1 or $2, so it's really nice. They're really cheap. So you'll need one of these. You will also need one of these sort of relay modules, and these are pretty cheap as well. I think they're also about $1 or maybe $2 on eBay, and I'm not actually going to use one of these here. I have a power cord that I have already incorporated a relay module inside of. So instead of rewiring and finding a new little mini extension cord, I'm going to use an existing one. But the basic idea is that I took a mini 1-foot extension cord and opened it up, and I connected the hot wire, which in general, if it's labeled correctly, is going to be the black wire in an AC cable. So I have gone ahead and wired the black wire, the hot wire, between the normally open and common connections on one of these relay modules. So usually you will have a little diagram on the bottom, and you'll see on this one, there's a little white kind of tab is connecting the center and the foremost wire here. So that is normally closed, that left connection, or this connection right here. But over here on this side, you have that sort of open, the line goes from the center and does not connect over to this one. So that's normally open. So that's the brains in the Digispark, or Digistump, and then a relay module to actually control the live wires. Now, the last components or part of this project is a button and a little pull down resistor here. So I'm going to connect these up to one of the pins on the Digispark, and then another one of the pins will connect to this relay, or this relay here. And when I push the button, it will automatically turn the relay on for a specific amount of time. So with any luck, it should be pretty easy to put together. The other components that I haven't mentioned here, I'm going to have a chunk of wire. I have a little JST connector, which can connect up to the pins that come out of the relay here. So that'll be connected to there, and then this wire, this cable here will connect to those. And the reason for this is that I don't plan on having this module sit right next to the relay, because this module is going to go on this little bit of circuit board here and have the button on it, and I plan on having the button either on the side or on the top here of the soldering iron. So I need a cable to go to where it plugs into the wall. I also have with me some male and female headers. This is a large chunk of female headers, but really all I'm using this for is to break out those pins to a male and female pair of headers, basically so that I can remove the ATtiny here, the Digispark, from the board so that I can upload programs and reuse it in the future. I always like to make sure that I have a way to reuse hardware in the future. And lastly, I have just some random little wires. I'm sure I'll need to make some little jumpers on this little circuit board here and connect everything up. So without any further ado, I think the first thing I'm going to do is solder these headers onto the Digispark and solder these female headers onto this circuit board. That way I have a good starting off point and I'll be able to plug this in, and from there I can wire everything else. Alright, so I've gone ahead and zoomed in the camera a little bit. And so I'm going to go ahead and solder this, the male headers onto the Digispark. And a little tip for some of you guys who might be starting out soldering here. When you're soldering header pins, or at least when I'm soldering header pins, something that I like to do is I like to actually stick the headers into a breadboard that I have handy and then maybe prop up the module a little bit. And that way it basically just makes it so that I am going to solder these pins nice and square on the unit itself. So I use this little trick for soldering basically any male headers, and it usually goes pretty well. So let's get this started. And there we go. That is the ATtiny Digispark soldered together. Now onto the female header pins, and for this I really don't have much of a trick. I just try, well, I guess the one trick I do have is that I will tend to solder just one of the pins on and then push it to the right position and then solder the rest of the pins along with that. And usually I can also get that to be fairly straight. Alright, I seem to have done it pretty straight without having any help even, so that's good. And now my plan for this is that it will just pop in like that, and then I have the rest of this little board here to play with to attach my button and everything else. So for this project, I have decided that pin 0 is going to be my button pin, and pin 5 all the way on the other side is going to be my relay pin. That way they're basically just as far away from possible from each other, and I don't confuse myself when putting it together. Alright, so the last little bit that we need to wire up from this is the power and ground. So these pins here are all just, I/O pins, but we're also going to need power and ground on this board, and that's through these 3 little pins here. So I actually didn't even think about this when I was putting this on, but I still prefer to have it facing like this rather than putting in 3 more female pins and having it mounted like this, because I want to be able to have my button mounted on this little board. So I'm going to put this way around, and I'm just going to take some of my wires here and just solder from there to wherever I want my power and ground to be. So I'm going to go ahead and do that, and then we'll be able to attach everything else. So there we go. Now I got those 2 little jumpers there connecting onto the board down the center. So that'll make it nice and easy for me to connect both my button and my relay pins to this to power them. So the next thing that I want to do is I want to tackle the tactile button. So this button is going to go onto pin 0. So that's the pin closest to me here. And what I need to do is the first thing I'm going to do is this button is going to have a pull down resistor. So that's what this little 1K resistor is here. And basically what that resistor does is while I'm not pushing the button, it electrically connects P0 to ground. So basically it gives the button a state. Without a pull down resistor like this, if you're not pushing the button, then there's no connection, right? So if there's no connection to anything, that pin isn't connected to anything, it doesn't know whether it's pressed or not. So the pull down resistor basically makes sure that if you're not pressing the button, it has a connection to something. Now, I have a 1K resistor here, but it is totally fine to use anything from about 220 ohms all the way up to 10 or even 20K probably would work. So we're going to stick this in, and then we're going to put the button on. Alright, and that's the pull down resistor done. Now I'm going to pop in the button. So on one side of the button, it connects to the 5-volt line. That would be the little white wire here. I didn't have a red one on hand. And it connects from there, and on the other side of the button, it connects to our P0. So when I push the button, it will make a perfect connection from 5 volts to P0, to our pin 0, and that will flip the switch on, so to speak. And that will in turn activate our relay. Alright, so there we go. We have power and our button connected. So now the last thing that we need to do is get the relay connected. Alright, so that should be it for the soldering. I don't think I've forgotten anything, so I'm going to go ahead and plug this into the relay now. Alright, and now all that I should have to do is put some software on this guy and push the button and test it out. So let's hop over to the computer now and just take a look at the software. It's pretty easy, so you guys should be able to follow right along. Alright, so here you can see the sketch we'll be using, and you can see it's quite short. So basically, it just reads the button, and just when it detects that you push the button, it turns the relay on. So up here at the top, the way we're going to read the button is through using the bounce to library. So this just does a little bit of debouncing on the button. It's not really necessary in this program, but I like the debounce library. It's nice and it's easy to use. So you can see here I've set up some macros just to make doing the math to figure out how long an hour is easier. And down here, you can see that here's our runtime. And so 2 hours should be plenty of time for me to do any project that I need to and keep the soldering iron and my house safe. So I'm going to do 2 times hour. And then down here I set up the I/O pins. So I have my relay pin on pin 5 and my button pin on pin 0. Now I haven't tested this program. I'm pretty sure that 5 and 0 are totally valid usable pins. I actually haven't used the Digispark before, like I said, so we're kind of testing it out here on the fly, but I think those values should work fine. If not, I may have to go and do some emergency soldering. And then I set up the debouncer. So this just creates an instance of the bounce library, and I will actually set it up and attach my pin in setup here. So in setup, I set up the relay pin, and just for good measure, I set the pin to low. I know it just automatically defaults to low, but I like to be, sure of myself, especially when dealing with AC and, things like that. And the next thing I do is I set up the button as an input, and I attach that button pin to my debouncer, and I set my interval to 50. Now, the interval is basically how long it takes for it to settle that signal. So then we come down into loop, and loop is really, really simple. We check the debouncer, we update it, and then we check to see if it rose. Basically, did we push the button? Did we go from a low signal to a high signal? And if we did, I'm going to turn the relay on, digital write relay pin high, and wait, just delay, for however long runtime is. For me, it's 2 hours. So it won't be perfect. The oscillators on these guys are not, perfect, but I don't really need perfect in this case. I just want to keep my soldering iron running for an hour or two, roughly, and then turn it off. Which is the last line here, to digital write the relay pin low, to turn the relay off. And that's it. That's all this program does. It just waits for the button to be pushed. When it is pushed, it triggers the relay, waits, and then turns it back off. So I'm going to go ahead and upload this program. Now, you'll notice I have a little USB hub here, and that's because on my computer I have USB 3. It's a MacBook with USB 3 on it. And when I bought these guys, I didn't know that basically they don't really work too well with USB 3. At least on Macs, they don't. So I have a USB 2 hub here that I can plug it in, and because this is a USB 2 hub, it's equipped to handle USB 2, and it communicates happily with the Digispark. Now, the reason that the Digispark doesn't work with the Mac or with USB 3 on the Mac is not so much because of backwards compatibility with USB 2 for USB 3, but because the DigiStump uses a USB library that's not fully compatible with USB 2, or so I've been led to believe. So when you plug it in, it just doesn't recognize it at all. It doesn't show up, can't upload programs, and I spent a good probably 45 minutes, maybe even an hour or two trying to figure this out. So for those of you who have a Mac with USB 3 on it, you will need some form of a USB 2 hub in order to upload programs. So let's go ahead and try uploading this. I'm going to plug this in. I'm going to hit upload, and hopefully it should upload to the Digispark. It looks like I still have some issue uploading code, so I will be back in just a sec and tell you guys what is up, and then we should be able to get going again. Alright, so I'm not really totally sure what happened there. Well, I know at least one issue. One issue was this little white USB cable I was using. I'm pretty sure that it was power only, so this did not have any data connections on it. So I spent about 5 minutes trying to figure that out. And then once I got that figured out, you can now see I got it uploaded. But you can also see here, I changed the relay pin. So I changed the pin that the relay was on from 5 to 4. So, and that's because in testing, once I got the program uploaded, it still didn't work right. So then I had to fiddle around a little while, and I figured out I'm not positive whether pin 5 is just broken on this little unit here, or whether there's some other issue, but it was not triggering my relay. So, not totally sure what's going on there. And so you can see though that if I power cycle this, I'm not totally sure if you can see, but if I push the button on here now, do you see the little red light on there come on? So the relay has now been activated. So this in theory is working as far as I can see here. You know, I got power. It's the red light for the relay is on. So the next step here is to actually plug this into the soldering iron and see whether it all works. So let's go and do that. Alright, so here you can see I have mounted my little Digispark, and I just mounted it using one of those little command strips, one of those little kind of pull away foam adhesive strips. And so here I have my soldering iron, and I'm going to put it into the on position, and when I push the button, there you go, you could see the screen came on. Now, I'm not going to sit here for 2 hours with the camera running, but I will leave a note in the comments letting you guys know if it didn't work. But I am fairly confident that this should work. Now, some improvements that I might want to make in the future, I was thinking about it, and I may want to modify the code so I can push the button to turn it off as well. But I think for the most part, I will just continue to use the on-off switch and basically use this as a safety mechanism. So I turn it on and then I push the button and I know I'm cleared for 2 hours. So I hope you guys liked this video and found it helpful and useful. Definitely let me know in the comments if you guys can think of any sort of similar uses to this. Maybe not a soldering iron, but maybe there's something else in your house that you leave on all the time that really should just be in a timed, device. But thank you guys for watching. If you like this video, definitely go ahead and click the subscribe button. And I will see you guys next time. Thanks for watching.